Hey everybody. I'm hoping you guys did pretty good with solving with the quadratics when you're factoring them and then setting them both equal to 0. We'll definitely do some more practice with that, as you can see, tomorrow. But today there's just one more thing I want to kind of talk to you about, and that is kind of reverse engineering our function based on a graph. And let me kind of tell you, we're basically going to do the same problems we did yesterday, just kind of backwards. So let's say I give you some solutions. I know the solutions of my function are x equals, what? Oh, actually I have them right here. Hang on. X equals 1 and -5. And you need to know something else too. You need to know the vertex is at -2, -9. Okay, so two parts of information. We know our solutions. We know our x-intercepts. It's going to cross the x-axis at -5 and 1. And our vertex of our function is -2, -9. Now what's cool here is we can actually come up with the function based off those two pieces of information. So think about what we know. I know that I would have set this up, right? So x, if one of my solutions is -5, that means I would have done x plus 5. And if one of my solutions is 1, that means I would have done x minus 1. Good. So that's kind of like my start off point, is we have these two functions and we know that we would set them up like that. Oh, and obviously it's going to equal 0, right? Which is important for us. So, oh, you know what else? We may have had, forgot about that. We may have had a GCF that we pulled out. So we're just going to leave A there just in case. Because if it is a GCF, right, if there was something else going on there, then we would definitely know about it from that situation with the A. Cool. So now, what do we actually know about this function? Well, we know that if I plug in -2 for x, I have to get out -9, right? So what I'm going to do is I'm going to do that exact thing. I'm going to take this -2 and I'm going to plug it in here and here. And then I know that when I do that, my answer on the other side turns into -9. Right? So I plug x in for all the x's. And then I'm going to take that and set it equal to whatever my y is going to give me. Okay? Makes sense so far, hopefully? So we wrote two factors based on our solutions. Throw the a in front. And we plugged in the x, we plugged in the y. Now we're just going to do a little bit of math, right? So -2 plus 5 is 3. -2 minus 1 plus -1 is -3. And then 3 times -3 is obviously -9. So we have a times -9 equals -9. And check this out. If I divide by -9, then I just get a equals 1. So basically the last step that I have to plug in here is, hey, I have to see, did I have a GCF here for my function? In this case, when I get down and solve it all for a, I find out that no, it was just 1. So what does that mean for me? Well, that means that my function here to actually solve this is just x plus 5 times x minus 1 equals 0. Or, obviously, I could put that in standard form and take it back out of factoring, depending on what you want to do with it. Add your like terms, x squared plus 4x minus 5 equals 0. And we can actually come up with what the function looked like from the solutions. That's pretty cool. Because when you think about linear stuff, if I would have told you like x equals 6, maybe you wouldn't have been able to come up with that. But then if I would have told you like the slope of a function is this and the y-intercept is this, it's kind of the same idea. Awesome. Let's do one more like that. And just come up with what we think our function would look like. All right. So this time, my solutions are going to be x equals 3 and 9. And my vertex is going to be at 6, negative 9. Cool. So we're going to set it up. If my solutions are positive 3 and positive 9, that means that in my factors, this would have been x minus 3, and this would have been x minus 9. And it's got to be set equal to 0. We throw the a in front because we don't know if it has GCF or not. We'll find that out in a second, right? So now we're going to plug in 6 for all the x's. And then our y value here is going to be negative 9. Do a little bit of math. 6 minus 3 is 3. Lots of 3's today. 6 minus negative 9 is negative 3. 3 times negative 3 is negative 9 times a equals negative 9. And again, this almost looks like the exact same problem. Divide and we get a equals 1. So it did not have a GCF because our a value is 1 in the front. Or I guess, yeah, a value is 1 in the front. So I know my function is just going to be x minus 3 times x minus 9 equals 0. Or if you would like it in standard form, we can FOIL it back out. X squared minus 9x minus 3x plus 27 equals 0. Add my like terms. X squared minus 12x plus 27 equals 0. So that's kind of a cool problem that we can do. We can take our factors, we can actually come up with our function based on whatever the vertex was, and we can go from there. Yeah, like I said, we're just going to kind of practice some more of this. This is very important problems that are going to be here to stay forever. So we definitely want to be experts at this before we kind of move on. I think it'll probably be good to do this the next couple of days. And then this is just kind of something from there that I thought would be definitely a good skill for you guys. All right, let me know if you need anything. I'll be around.